So let's work number 44 on the homework. And it says that we have one equation that is 3x plus 4y, and that equals a negative 2. And we have another equation that is negative 4x minus 5y, and that equals 9. Now, the way we're going to solve for x and y for both of these is we're going to set up a matrix. Now, to set up a matrix for two equations like this, what we're going to do is we'll have one matrix where we put just the coefficients in. So the first one is a 3, so a 3 will go there. And then this one right here is a 4, so next we'll put in a 4. And on the bottom part, we have a negative 4 right here. So I'll put in a negative 4. And then over here, I have a negative 5. So I'll put negative 5 right here. Now, it's important that whenever you do this, you have to make sure the x's are lined up and the y's are lined up. Because if you don't, you'll get these numbers in the wrong spots. So the first thing is make sure that you have the x's and the y's on one side and the numbers that don't have a coefficient on the other side. So the next part that we're going to do is we're going to have another matrix, and I'll have the x up top because it comes first, and then what comes next is the y, so I'll put a y down here. So I have these two matrices multiplied together, and they're going to equal another matrix. We'll have a negative 2 up here, so I'll put negative 2, and then I have a 9 right here, so I'll have a 9 there. Now, if we wanted to multiply this matrix times this matrix, it will give us these two equations up here. But you can do that on your own or watch the other video that I made on multiplying matrices, and this will be pretty good practice. So if you can multiply this matrix times this matrix and get these two equations, then that means that you're doing this right. So what we're going to do to solve this matrix, because we're going to solve for x and y only using the matrices, let's make a side note over here. So something a little bit separate. Now, if we have, let's say 4x equals 8, and I want to solve this for 4, what I'm going to do, this is back in Algebra 1, what I'm going to do is I'm going to multiply this by a 1 over 4. Now, you may have been taught to divide by 4, but multiplying by 1 over 4 is the same thing as dividing by 4. Because we have 1 times 4 would be 4, and then we're going to do, remember there's a 1 down here. You can take any number and divide it by 1, and you'll get that same number. So we have 1 times 4 is 4. 4 times 1 will be 4. So 4 divided by 4 is going to be 1. So all of this would go away. And I made all this go away by simply just multiplying by this right here. So this and this are called inverses. This is the 4 that I want to get rid of, and I'll multiply it by the inverse, which is 1 over 4. So by multiplying by 1 over 4 times 4 over 1, that makes all this go away, and I have x by itself. So if I did this to one side, I have to multiply this by 1 over 4 on the other side. Now remember, there's still a 1 right here. So we have 8 times 1 will be 8, and then we have 1 times 4 will be 4. And 8 divided by 4 is going to be 2, so we have x equal to 2. Now, if we can apply the same concept, the same idea to these matrices right here. So if we can find the inverse of this, think of this matrix as the 4 and what we just did. So think of this matrix as a 4 and this right here as the x that we don't know, and this is going to equal some number over here, 8. Let's say this represents the 8. So basically, if we multiply this matrix by the inverse of this matrix, it'll make this whole thing go away. Now, if I multiply that inverse by this side, I have to do the same to the other side. I can multiply by the inverse over here as well. So that's essentially what I'm going to be doing to solve for this. So let's find out what the inverse of this is, and then if we multiply that inverse, whatever that is, times this, makes this go away, and multiply by this over here. So to get the inverse of this, I already did a video on that. So if you're confused about how to find an inverse, go watch that video. So first things first, and we have to get the determinant of this matrix. So to get the determinant, I'm going to do a -5 times a 3, and I'll take that number and then subtract it by, I have a -4 times 4. Now -5 times 3 will be a -15, and I'll subtract that by -4 times a 4 will be a -16. So the determinant of this matrix right here would be -15 minus a -16. So a negative and well, minus and a negative, that's the same thing as plus a positive. So if you want to change the signs though to make it to visualize a little bit better, you can do that. So if we have addition now, we have a -15 plus a positive 16. So what I'm going to do is just do -15 plus 16. That will be a positive 1. So the determinant of this matrix is going to be a 1. Now what I'm going to do with that is I'm going to use that inverse equation from that other video and find out what the inverse of this is. So that equation is 1 over the determinant, put 1 over det, and that's going to equal this matrix right here. We're going to switch these two numbers. The -5 and this 3 are going to change spots. So the 3 will go here, the -5 will go here. Now I'm going to change the sign of this 4 and of this 4. This is a positive 4, so it's going to become a -4. This is a -4, so it will become a positive 4. So it kind of looks like I switched these two numbers, but I didn't. All I did was I switched these two numbers, the 3 and the -5. I switched those, and then I changed the sign of these two. So the determinant we already said was a 1. So I'll replace the det with a 1. And I'm going to take those two numbers, this right here and this right here, and multiply them. So I'll have 1 over 1 will be 1, and I'll distribute this to each part of this. So 1 over 1 is 1, so this is really not going to change this at all. So I'll have a new matrix of -5, 4, -4, and 3. So this is going to be the inverse of this right here. Now again, if you're confused, I made a better video on how to find the inverse, but I kind of sped through that, and what you should get, which should be this matrix right here. You should have got this. So let's erase all this. Now I'm going to do this times this right here times this will make this go away, and there's not enough room for me to put this matrix over here, but if I did, it would just go away, and I'll have x and y by itself. So I did that to this side, let's do that to this side over here. So what I'm going to do is I'm going to multiply matrices. So I'm going to circle these two right here, and then I have these two right here. And make sure I don't cover up that negative sign right there. So we're going to start from the left and then go right. And then for this matrix, we're going to start from the top and then go down. So I'm going to have a -5 times a -2. -5 times a -2. And that'll be some number. And then we're going to add that to, we're going to move right, start left and go right. I got -4 times a 9. So we're going to have -4 times a 9. So if we do -5 times a -2, that'll be a positive 10. And then I'll add that to, we got a -4 times a 9, that'll be a -36. So if we add these two up, we'll have 10 plus -36, that's going to be a -26. So this would be the top, because I did the top row, and then we have the column right here. So this is going to equal This will be the top part. So I got negative 26 there. Now let's do the bottom part. The bottom is going to be this row. So we have a 4 times a negative 2. That'll be a negative 8. And then we have 9 times 3. That'll be a 27. So we add up negative 8 plus 27. That'll be 19. So 19 will be the bottom, and it'll be this middle right here. So we'll have a 19 there. So now I can erase all this, and you should already know how to do this from the other video. So to get more room, let's just go ahead and erase this right here. And this times this will equal this right here. So this will be the answer. This is going to be the x. This right here will be the y. And if you want, you can check your answer by taking one of these equations, doesn't matter which one, and putting them in for one of these equations and see if this statement is true. And it should be true because this is the x and this is the y.